Hi, this is a recording of a session I've created for Data Relay on DBA Dash. Some information about me. I've got 19 years experience working in IT, 17 years as a DBA. I work for Trimble, a technology company that spans numerous industries, including construction, agriculture, geospatial, transportation and infrastructure. I support multi-tenant software as a service databases. I look after around 40 regular SQL instances and over 100 Azure DBs. Trimble has thousands of SQL instances. Monitoring and performance tuning is a big part of my role. Outside of work, I enjoy running and I'm a member of the Sunderland Strollers. This session's all about DBA Dash. So what is DBA Dash? It's an open source monitoring tool for SQL Server. It does performance monitoring, daily DBA checks, and it can track configuration across your SQL Server estate. So how does it work? DBA Dash runs as a Windows service. It can collect data from your monitored SQL Server instances, and it pushes the data into a central repository database. There's a Windows application that can be used to report on the data collected. There's also a service configuration tool that you can use to set up the service. It's also possible to set up a DBA Dash service in a remote environment, collecting data from monitored SQL instances. Instead of pushing the data directly into the repository database, it's possible to push it into a S3 bucket. You then have another DBA Dash service that pulls the data from the S3 bucket and pushes it into the repository database. You don't need to use a S3 bucket, but this scenario allows you to establish connectivity to remote environments. For the first demo, we're just going to show you how easy it is to get up and running with DBA Dash. So after we've got DBA Dash downloaded from GitHub, we just run the DBA Dash service configuration tool. The first thing we need to do is set a destination connection. This is the connection to our DBA Dash repository database. We just enter the server name, and the default database name's DBA Dash DB. Click connect. The database will get created when the DBA Dash service is started. Click the source tab. We're going to add some connections to monitor. Just click add update. And we're going to add another instance. This time we're going to click the extended events tab. We're going to capture slow queries for this monitored instance. And we're also going to collect plans for running queries. And we're going to enable database schema snapshots as well. Click add update. And there we have our second monitored instance. Once you've added your monitored instances, we just go back to the destination tab. We save our configuration, and then we click install as a service. Click install. Here we need to enter the username that the service will run as. The service is now installed. The only thing left to do is to start the service. We can click view service log, and we can see that if we just keep refreshing, we can see what it's up to. So the first thing it'll do, it'll start deploying the DBA Dash database. You can see it's started the collections now. So if we click refresh, we see that the service is running. We can then load the DBA Dash GUI. And we can see we already have data collected. For the second demo, we're going to look to see how we can use DBA Dash to investigate a performance issue. The performance issue was reported for the server Lab 2022. So we're going to go to that server, and we're going to go back in time. So we're selecting the hour period here where the performance issue was reported. On the performance summary page, we can see a summary of our performance metrics. And when we start going to the performance tab, the first chart at the top here shows SQL Server CPU utilization. The blue in the chart is the SQL Server process. The red is any other process consuming CPU. The second chart shows disk I/O. Here, similar to the CPU chart, there's not really much going on in terms of disk I/O. We're hitting about 6 megabytes a second maximum with good disk latencies. The third chart shows weights. Weights are a really good indication of what type of performance problem you're looking at. And we can see here suddenly there is a significant increase in a particular weight type. If we hover over, we can see what the weight type is. In this case, the weight type's LCKMS, which is a block and weight. What we can also see in the next chart, we can see some bubbles here. These bubbles represent blocking. The larger the bubble, the higher the blocking duration, and the higher up the chart, the more sessions have been blocked. And the last chart on our list here shows stored procedure execution stats. So we can see there's a stored procedure called get post info. That's 67% of the total duration. There's also a get summary, that's 32%. So these stored procedures might be worth investigating. The first thing we're going to do is to investigate the blocking. We can do this by clicking on the bubble here. And here we get a running queries viewer that shows us the root blocker. So this is the query causing the blocking. We can click to see what the query is. And we can also navigate down to see what queries are blocked behind this query. We have 2 queries that are directly blocked by this query, but recursive, we've got 25 queries blocked behind this query. And you can drill down and you can see what queries are blocked. You can also clear the blocking filter and just show all the sessions that are being captured in this running query snapshot. So what can we see here? We can see the blocking sessions. We can see the ID of the blocking sessions. So this session here, 77, is blocked by session 76. We can also see the blocking hierarchy. So the first ID listed here is the root blocker. So in this case, this session here is blocked by session 77, but session 77 is blocked by 76. We can easily see which is the root blocker. It's highlighted here. And we can also see the total amount of wait time for the block queries. So this is the top one here is the query that's causing all the blocking. So there's a couple of interesting things about this blocking scenario. The first thing we can see is that the status of this session here is sleeping. This means that this query is no longer doing any work, but what it has done, it's left a transaction open. That transaction's causing the blocking. So we need to investigate fixes from the application side to ensure that the application's not leaving connections open, not leaving transactions open, and it's using as short transactions as possible. We can also see that the query actually completed sort of pretty quick. The CPU logical reads, it's all very low for this query, but the query's been left with a transaction open for 58 seconds. So it's been running for a minute, and it's starting to cause problems because it's left a transaction open. So what about the queries being blocked themselves? It's worth looking to see what's being blocked. So we can see a get post info stored procedure being blocked. We can also click here and see what the statement is. And what's interesting here is that the queries being blocked are not updates or deletes, and here it's a select statement. That's interesting because we can in SQL Server use something called read committed snapshot isolation. If you have that enabled for your database, then you have a situation where readers don't block writers. The default isolation read committed. You can have readers blocking writers, which is what we've got in this case. So one fix to help with this type of blocking, where you've got select queries being blocked by update queries or vice versa, is to look into read committed snapshot isolation level. What we can also do, we can also go to the Running Queries tab, and we can see a snapshot. We can see a full list of the Running Query snapshots. We can also sort this by the number of queries being blocked, and we can click to view a particular snapshot. And that's the same information that we saw when we clicked on the blocking bubble. The other thing we have is slow query capture. This captures RPC and batch completed events. We can click to drill down, and we can see the captured queries. In this case, it gives us all the parameter information that was sent from the client application. We also have the option to drill down and see if there's any sort of running query snapshots. We can see what this query was doing at particular points of its execution. So here we can see what the query was doing 25 seconds into its execution, and we can also see what was happening 1 minute 25 seconds into its execution. The running query snapshot by default runs every minute, so we'll have a snapshot of a query's execution every minute by default. You can also change that as well if you wanted to take a running query snapshot every 30 seconds. You can customize the application to do that. So we can see in both cases this query is being blocked. We can click the Weight tab, and this shows us the most relevant weight types. So we can see the top weight type for this hour period is LCK-MS. And it's also possible to click a weight type, and we can see that weight type over time. So we can see the wait time and the signal wait time over the hour period. We can see where we've hit some problems here with some blocking. So this is a recap of our blocking demo. LCK weights indicate blocking. We can use the Running Queries tab to highlight our root blockers. The root blocking in this case was caused by a sleeping session. So an application fix is required to ensure that the transaction isn't being left open. The queries in this case that were being blocked were select queries. We could look at read committed snapshot isolation to fix this. In other blocking scenarios, we generally look at the queries causing the blocking, starting with the root blocker, and tune those. We should keep transactions as short as possible to avoid blocking. We've got another performance issue to investigate on this server at 9:10. So for this next demo, we just need to change the date range. We'll go back to the Performance tab. We can see there's very little CPU or I/O utilization at this time, but we do see an increase in a particular weight type. Hovering over here, we can see there's an increase in async network I/O weights. We can also see the stop procedure execution statistics. We can see 99% of the durations associated with extract posts. We can also click the Weights tab, click the async network I/O, and we can see that there's been a significant increase in network I/O weights during this period. We can click the Running Queries tab, We could sort this by the number of running queries, just pick a snapshot to view. So we can see we've got a few queries running here that's being captured, and the wait type for these queries is async network IO. We can also see that this was calling the extract post store procedure. We can see the login name, database, application name. What we can also do is click on the Slow Queries tab. We can see that we've got quite a few queries in this 1 to 5 minute execution time range. We can click to drill down. Here we can see that we've got a few captures here for the async network IO demo app. These queries are executing in about 1 minute 48. Here we can click on the text and we can see the what statement the client executed with all the parameters. We can also drill down, click the session ID, and we can see a snapshot of running queries that are being captured while the query was running. So in this case, we can see 50 minutes into the execution. We can see that this query was waiting on async network IO. We can click a few of these, and we can see the same pattern. These queries have been waiting for async network IO. We can also see the stats here. We can see the high durations, low CPU, and low amounts of IO. So we're starting to see a pattern here. The wait is async network IO. This can indicate that there's a performance problem from the client application side rather than SQL. It can also be an indication that the client's requesting large amounts of data from SQL, or it could just be that it's taking a long time to process the data. This is a recap of our async network IO demo. High async network IO waits indicate that there's a problem from the client side. The application is slow consuming the result set. It could be the application is experiencing issues. The application could also be requesting a very large result set. We could look at options to reduce the amount of data returned. For example, we could review the where clause, see if there's some way we can filter the data some more. We could implement paging. Also, if we send in large result sets back to the client for the client to do aggregations, we could consider doing those aggregations in SQL. It could indicate slow network connectivity, but that's not necessarily the case. So now we're going to go look at a different performance issue on a different server this time, Lab 2014. So we're going to change our database to Lab 2014, and we're going to change the date range. So in this case, we can see a significant increase in CPU utilization. We also see an increase in I/O. It's worth keeping in mind the scale of this chart. We're only seeing throughput of 10 megabytes a second. So the increase in I/O is not really that significant. And we also see in sort of good disk I/O latencies. The weights again is key to understanding what's going on. In this case, we see a significant increase in page latch up weights. Those are different to page I/O latch weights, which would indicate an I/O bottleneck. Page latch up weights are an in-memory weight. We also see some blocking. Because these blocking bubbles are small, the wait time for these snapshots isn't particularly large, but there is a large number of queries being blocked. We can also see there's a stored procedure called TEMPDB stress that is suddenly started to be executed. We're seeing a high total duration for this, which might give us an indication of what the problem is. We can click on the block and snapshots. We can clear the block and filter just so we see we're seeing all the sessions being captured, and we can see a lot of queries being blocked here. The wait type is page latch up, and if we scroll all the way along to the right, we can see the wait resource. We can see a lot of wait resource beginning with 2, which is TEMPDB. We also see the wait database here. The other thing we can see the page type. So the page type is PFS, which is page free space. So in this case, we see in TEMPDB contention, this contention on the special pages that TEMPDB is using to work out where to put this data. We can also go to the Running Queries tab. This has a summary of the running query snapshots. We can sort by the number of running queries. We can also sort by the TEMPDB wait count. So this top snapshot here, we've got 50 queries waiting on TEMPDB. Again, we can drill down, and this is basically just the same as what we saw when we clicked the block and bubble earlier. Again, you've got the weights tab. You can click on the page latch up wait type, and we can see that wait type suddenly increase. So we can see where we've had this TEMPDB contention issue. This is a recap of our TEMPDB contention demo. Page latch waits could indicate TEMPDB contention. The running query snapshots can confirm this. So we're looking at the wait resource. Wait resource starting with 2 is TEMPDB. We can check the page type column. Typically, we see contention on allocation pages, such as page free space, global allocation map, and shared global allocation map. We might also see other listed. This can indicate metadata contention. In this case, you can use DBCC page, and that can identify the object that you're seeing contention on. So what are the fixes for TEMPDB contention? The first most important fix is just to make sure that you've got your SQL Server patch with the latest cumulative update. There's been significant fixes for TEMPDB contention in later cumulative updates. We could consider upgrading to a new version of SQL Server. We should also check our TEMPDB configuration, follow best practices, and if we start seeing allocation contention, consider adding more files. We should ensure that our TEMPDB files are evenly sized. We can also look at tune our workload. So we can remove temp tables in places where we can, particularly where we're inserting lots of data into the temp tables, or if we're creating temp tables frequently. We can look to insert less data into temporary tables. We could look at caching to reduce the load on the DB server. If we've got SQL Server 2019, we could look at in-memory TEMPDB. That's the in-memory TEMPDB is to fix metadata contention. Also around metadata contention, we should ensure that we're using cacheable temp tables. So when you create a temp table and you're finished with it, SQL Server will go ahead and reuse that temp table for the next execution. That's cacheable temp tables. There's certain things you can do that will prevent the caching, and if you're not using cacheable temp tables, then you're likely to see more contention. So some things to avoid is creating indexes after the temp table's been created. That will prevent caching. Also creating temp tables within dynamic SQL will prevent those tables from being cached. That completes the performance demos. There's still areas of the application we haven't explored yet, such as the memory tab, metrics, object execution, Azure DB monitoring, and agent job performance. We'll take a brief look at those, and then we'll move on to daily checks and configuration. The memory tab shows us where memory is being used in SQL Server. We can see the various memory clerks and how much memory they're using. You can click on a particular memory clerk and see its usage over time, or you can see the pie chart for the current usage. It's worth looking at this tab. Sometimes you can have problems with certain memory clerks, such as user store token perm. If this gets particularly large, that can sometimes constrain your query plan cache. You'll start seeing high query compilations a second, and then that can cause high CPU utilization. We've got a metrics tab where we can see various OS performance counters. It's also possible to collect custom metrics in here. You can click on any metric and see a chart over time. It's also possible to add some other charts in here, such as CPU, object execution, and you can create your own custom dashboards. You can save them, you can reload them. The object execution tab gives us stored procedure execution statistics. You can see the summary, which stored procedures the highest in terms of total duration. We can click on any of these and we can see the performance of the stored procedure over time. We also have monitoring for Azure DB. This DBA Dash testing is a Azure database. We can click on here. Here we have an Azure summary. We can see the usage of the database. We can see what's used in terms of DTUs. And we can use this tab to see if the databases are suitably sized. We can also click on these to get some charts over time. You can see the max CPU, max data, and max log write. If we expand an instance, if we click on jobs, we can see the job stats tab. That gives us a summary of the job executions within the selected time period. We can click on a job and we can see its performance over time. So now on to the daily checks and configuration demo. DBA Dash can also track your SQL Server configuration. If we click the configuration tab here, we can see all the sys configuration settings that we've got enabled for our SQL Server instances. Where we've got highlighted here is where we've changed some of the defaults. We can filter this for just where the configured only. We can see where we've made changes and where there's differences between our SQL Server instances. So some things you might want to configure is cost threshold for parallelism, max degree of parallelism, max server memory. We might want to have backup compression, backup checksums. These are some of the things that you might want to change. And what this also does, it tracks when changes have been made. So we can see the current state here, and we can also see when changes have been made. So we can see the recent changes. It also tracks trace flags, so we can see what trace flags are enabled, when trace flags have been added or removed. On the hardware tab, we can see information about the processor, SQL version. We can see if we've got lock pages in memory enabled, if we've got any offline schedulers, our power plan, there's a check to see if that's high performance. We can also see if instant file initialization is enabled. SQL patching tab shows us what cumulative updates we've got installed for our SQL servers. We can check what alerts we've got enabled. We can check drivers. We can check our TEMPDB configuration. So you can see that some of our servers are highlighting that we've got insufficient TEMPDB files. So we can check the configuration. On older SQL instances, it's recommended to have 2 trace flags enabled. So these have been highlighted for our older SQL instances. It's also possible to have memory optimized TEMPDB on our newer servers. So it's highlighting that we don't have that enabled on some of our newer servers, but it is available. It tracks our resource governor configuration, its user service objectives, resource governance. It tracks database level configuration settings, such as the database level max degree of parallelism, and it'll track when those changes have occurred. You can see a summary of your database options, so it can highlight if you've got page verification set to on page or none. That will highlight here where you should have it set to checksum. It'll also highlight if you've got high VLF counts for any of your databases. It's shown the max VLF count, and you can always click detail, and you can see all the detail for all your SQL Server instances. Again, you've got reporting for Query Store, so you can see a summary of Query Store, see if there's any if any's gone into like a read-only mode. It'll highlight those sort of problems. We've also got some system tags that get created for our SQL Server instances. We can use these tags for filtering purposes, so you can say a CPU count 1, and it'll filter the servers with 1 CPU. It's also possible to add your own custom tags to your to instances. Go to configuration, tags, you can add your own tags. So you might want to add a tag for SQL role, production, QA, add those tags in, and then you can use that for filtering your instances. You can also search for your instances here. So just to wrap up the presentation, if you need help, go to the website dbadash.com. We've got a brand new website with some help. We've also got documentation on GitHub. There's issues and discussions on GitHub. There's a SQL community Slack, and there's a channel DBA Dash on there where you can use to ask questions and get answered. I hope you enjoyed this presentation. Thank you.